Okay, in this problem, you are given three vectors, vector A, vector B, and vector C. And you're asked to find within bracket vector A cross product with B, cross product with C, and vector A cross product with B, cross product with C within bracket. So we'll do the first one. Vector A, C can be written as vector A dot product with C, vector B minus B vector A. Okay, so doing the dot product first with A and C, we get 1 times 3 is 3, minus 2 plus 2 minus 4, 3 and 1 plus 3, vector B minus B into C now. 2 into 3, 6, 1 into 2 plus 2 minus 2 into 1 minus 2 A vector. So that will be equal to 6 minus 4 2B vector minus 6A vector. Okay, so now let's substitute the values of the vectors. So that is 2 times vector B is 2I vector I cap plus j cap minus 2 k cap minus 6 times I cap minus 2 j cap plus 3 k cap. So further simplifying this, you get 4 I cap plus 2 j cap minus 4 k cap minus 6 I cap plus 12 j cap minus 18 k cap. Further simplifying, we get minus 2 I cap plus 14 j cap minus 22 k cap. Okay, so that's our answer. Now let's do a second problem. Here you're asked to find vector A cross product with B cross C within bracket. So this can be written as A dot C B minus A dot B C. So that's equal to, doing the cross product of A and C, we will get 1 times 3 is 3, minus 2 and plus 2 will be minus 4, 3 and 1 will be plus 3, vector B minus cross product with A and B, 1 into 2 is 2, minus 2 into plus 1 minus 2, 3 into minus 2 minus 6, C vector, and that's equal to 2B vector minus, so it becomes plus 6C vector. Okay, now substituting the values of vector B and C, 2 I cap plus j cap minus 2 k cap plus 6 times 3 I cap plus 2 j cap plus k cap. So for the simplifying, 4 I cap plus 2 j cap minus 2 k cap plus 18 I cap plus 12 j cap and plus 6 k cap. So further simplifying, we get 22 I cap plus 14 j cap plus 4 here, so plus 2 k cap. Okay, in this question we have to, for any vector A, prove that I cap into cross product with the A vector cross product with I cap within bracket plus J into A cross product with J and K into A into K is equal to 2A. So let's take the first one. So it is I cap into vector A into I cap. Before that, let me define my vector A as A1 I cap plus A2 J cap plus A3 K cap. So this can be written as I cap vector A minus I cap vector A I cap. Okay, so we know that I cap into I cap is 1. So we get vector A minus, and I cap into vector A will be equal to A1. So it will be A1 I cap. So let's go to the second one now. J cap into vector A into J cap can be written as J cap dot product J cap vector A minus J cap A vector A J. So that will be equal to J and J will become 1. So vector A minus J cap into vector A will be A2 J cap. That's our 2. Then the third one, K cap into vector A into K cap will be equal to K dot product K vector A minus K dot product with vector A K cap. That's equal to K cap into K cap will be 1. So you get vector A minus K cap into vector A will be A3 K cap. Now adding 1, 2 and 3, we get 3 A vector minus A1 I cap plus A2 J cap plus A3 K cap. So this can be further written as 3A vector minus A vector, which is 2A vector. Therefore, I cap A into I cap plus J into A J cap plus K into A into K cap is equal to 2A vector. So that proves our required question. Okay, in this question, we are asked to prove the scalar triple product A minus B, B minus C, C minus A is equal to 0. Okay, so let's expand and write the left hand side. So our left hand side is the box product, which is A minus B, comma, B minus C, comma, C minus A. Okay, so that's equal to minus B dot product with B minus C cross product with C minus A. Okay, so it's like you have three vectors and using our scalar triple product expansion. Further expanding the terms within the brackets. Okay, we leave this A minus B as such. And then we start to expand this, which is within the brackets here. So this will be using the distributive law, B into C. So B, C, then you have minus B into A, then minus C into C plus C into A. Now we know that this is equal to 0. C into C will be equal to 0. So we get A minus B within bracket B into C minus B into A plus C into A. Since this is equal to 0. So further expanding this, you get, this is the dot product here, vector A dot product with B cross C minus A into the second term dot product with B cross A plus A into C cross A minus B into dot product with B cross C plus B dot product with B A minus B dot product with C A vector. Now all these vectors, which is A dot product with B into A, then A dot product with C into A, B dot product with B into C, B dot product with B into A. All of these will become 0 because you have repetition of the same vector inside. So this will become vector A dot product B cross C minus 0 plus 0 minus 0 plus 0. So it's minus vector B. So you are left with two scalar triple products. So this can be written as A, B, C minus B, C, A. Since they are in the same cyclic order, we can rewrite A, B, C minus A, B and C, since they are in the same cyclic order. So that is equal to 0. That proves our question. In this question, we are given three vectors, vector A, vector B and vector C. And you're asked to prove the question number 1, which is A cross B cross C, which is a vectorial triple product, is equal to A dot product with C, B vector, minus B dot product with C, A vector. And then you're asked to prove this second one. Okay, we'll start with the first one. So to do the first one, let's take the left hand side and let's find what is our A cross product with B. So we know that A cross product with B can be written as determinant of I cap, J cap, K cap. A is, the coefficients are 2, 3, minus 1, and for B it is 3, 5, and 2. So that is equal to 3 times 2, 6, 6 minus 5 will be plus 5, I cap minus J cap into 4 plus 3 plus K cap into 10 minus 9. So this is nothing but 11 I cap minus 7 J cap plus K cap. Okay, so now let's find here vector triple product. So that will be equal to so that will be equal to I cap, J cap, K cap, and our A cross product with B is this. So let's bring the coefficients here. 11 minus 7, 1, and our vector C is, coefficients will be minus 1, minus 2, 3. So that's equal to minus 21 plus 2 I cap minus of 33 plus 1 J cap plus minus 22 minus 7 K cap, and that would be equal to minus 19 I cap minus 34 J cap minus 29 K cap. Okay. Now let's do the right hand side. So this is our left hand side. Now let's do the right hand side. Right hand side is dot C. I'm just copying from up. Doing the A dot product C, you get 2 times minus 1, minus 2, 3 times minus 2, minus 6, minus 1 plus 3, minus 3, vector B, minus of, now B times C would be 3 into minus 1, minus 3, 5 into minus 2, minus 10, 2 into 3 plus 6, A vector. So that is equal to minus 11 vector B, minus 13 plus 6 will be plus 7 A vector. So now let's substitute B and A vector in this equation. So minus 11 into vector B is 3 I cap plus 5 J cap plus 2 k cap plus 7 times a vector would be 2 I cap plus 3 j cap minus k cap. So for the expanding them, we get minus 33 I cap minus 55 j cap minus 22 k cap plus 14 I cap plus 21 j cap minus 7 k cap. So further simplifying, we get minus 19 I cap minus 34 j cap minus 29 k cap. So we can see that our LHS is equal to RHS, hence our proof. Now let's do our second part of the question. Okay, so again we need to find the vector cross product of A cross B cross C. So let's first find what is our B cross product with C. So that will be equal to the determinant of I cap, j cap, k cap, and the coefficients are 3, 5 and 2, and for C the coefficients are minus 1, minus 2 and 3. Solving this, we will get (19) I cap minus 11 j cap minus k cap. Now let's do A cross product with B and C. So that would be equal to I cap, j cap, k cap, and our A is coefficients of I, j and k will be 2, 3, minus 1, and bringing our B cross product with C here, we have 19 minus 11 minus 1. So further solving this, we will get minus 14 I cap minus 17 j cap minus 79 k cap. Okay, now let's do the right hand side. This is our left hand side. Okay, this is our left hand side. So right hand side would be A, C. I'm just bringing whatever was up there. Okay, so now first A dot product with C will be minus 2, minus 6, minus 3, vector B minus 6 plus 15 minus 2, vector C. So this is nothing but minus 11 B vector minus 19 C vector. Now substituting the values of B and C, we get 11 into 3 I cap plus 5 j cap plus 2 k cap minus 19 into minus I cap minus 2 j cap plus 3 k cap. So further expanding this, we'll get minus 33 I cap minus 55 j cap minus 22 k cap plus 19 I cap plus 38 j cap minus 57 k cap. So simplifying this, we will get minus 14 I cap minus 17 j cap minus 79 k cap. So that's our right hand side. So left hand side is equal to our right hand side. In this question, you're given three vectors, vector A, vector B, and vector C. So you're asked to find the dot product of A cross B and A cross C. So A cross B dot product with A cross C will be equal to the determinant of A dot A dot C, B dot A, and B dot C. So further expanding this, okay, A dot A will be 4 plus 3 squared is 9 plus 1 squared is 1. Similarly, A dot C will be 2 plus 3 minus 1, and B dot A will be minus 2 plus 6 plus 4, and our B dot C will be minus 1 plus 2 minus 4. So further simplifying this, we can get this is equal to 14. 2 plus 3 minus 1 will be 4. 4 plus 4, 8. And this is minus 3. So that's equal to minus 42 minus 32. And that is minus 74. So our answer is equal to minus 74. In this question, we are given 4 vectors A, B, C, and D, and they are all coplanar vectors. We need to prove that A cross B cross product with C cross D is equal to 0 vector. So what is given to us is vector A, B, C, and D are coplanar vectors. Okay, so let's solve A cross B cross product with C cross D. So this can be written as A cross product with B dot D C vector minus A B dot C D vector. Okay, now if you see this this is a scalar triple product. So we can write this as our box product A, B, D, C vector minus A, B, C, D vector. Since A, B, C and D are coplanar, our A, B, D will be equal to 0 and A, B, C will be equal to 0. Therefore, you will get our given requirement will be equal to 0 times vector C minus 0 vector D. So that is equal to 0 vector. That proves our given condition. Here we are given if vector A, vector B, vector C and the vector triple product A cross B cross C is equal to L into vector A plus M into vector B plus N into vector C. Then find the values of L, M and N. So we need to first find vector triple product. This can be defined as minus A dot C dot product and A dot product with B. So to find A dot product with C, you need to cross multiply the coefficients of the I, J and K and add them up. So the coefficients of I is 1 and 2, 3 for A and C. So it's 3. Similarly, J is plus 4 plus 3 B vector minus for A into B will be 2 minus 2 plus 3 C vector. So that's equal to 10B vector minus 3C vector. Now substituting the values of vector B and C and multiplying them with 10, we will get 20 I cap minus 10 J cap plus 10 K cap. Similarly, 3 times of C vector would be 9 I cap minus 6 J cap minus 3 K cap. So further simplifying this, you will get 11 I cap minus 16 J cap plus 7 K cap. Okay, so now we have this. This is actually equal to LA vector plus MB vector plus NC vector. So let's expand on this part. So that will be L into I cap plus 2 J cap plus 3 K cap plus M into 2 I cap minus J cap plus K cap plus N into 3 I cap plus 2 J cap plus K cap. Now this is equal to 11 I cap minus 16 J cap plus 7 K cap. So we can say that taking the coefficients of I from this equation, we can say that L plus 2m plus 3n is equal to 11. Similarly, we can say 2L, which is the coefficients of J. Now, 2L plus, minus m plus 2n is equal to minus 16. And now taking the coefficients of k cap, 3L plus m plus n is equal to 7. So we have three equations here. Now let's call them as equation 1, 2, and 3. Trying to save space. So if you multiply 1 with, let's multiply 2 with equation 2 with 2 and add it with equation 1. So let's say equation 1 is L plus 2m plus 3n is equal to 11. Now multiplying the second equation with 2, we will get 2 into 2. We get 4L minus 2m plus 4n is equal to minus 32. So add the two equations, you will get 5L plus 7n is equal to minus 21. Next, let's add 2 and 3. So if we add 2 and 3, we will get 2L minus m plus 2n is equal to minus 16. Add it with 3L plus m plus n is equal to 7. You will get 5L. This will, m will become 0 plus 3n is equal to minus 9. Now solving for, or let's call this as equation 4 and equation 5. Let's make some space here. Okay. Equation 5. So solving these two equations or subtracting 4 minus 5, we will get 5L plus 7n is equal to minus 21 minus 5L minus 3n is equal to 9. So you will get your answer here as 4n is equal to minus 12. Therefore, our n is equal to minus 12 by 4, which is equal to minus 3. Now let's substitute this value in 4. So we have 5L plus 7n is equal to minus 21. And substituting the value of n here, so you get 5L plus 7 times minus 3 is equal to minus 21. So you get 5L minus 21 is equal to minus 21. So 5L is equal to 0. So our L is equal to 0 here. And the last, let's substitute in the third equation, in equation 3, which is 3L plus m plus n is equal to 7. So substituting the values of N and L. You will get L is 0, so M plus NS minus 3 is equal to 7. So M is equal to 7 plus 3, that is equal to 10. Therefore, L is equal to 0, M is equal to 10, and N is equal to minus 3. That's our answer. Let's read the question. The question says, if A cap, B cap, C cap are 3 unit vectors such that B cap and C cap are non-parallel, and A cap into B cap into C cap is equal to half of B cap, then find the angle between A cap and C cap. So we are given that B and C are not parallel, and also we are given this result, which is A cap into B cap into C cap, which is a vector triple product, is equal to half into B cap. Now, before we go into the problem, I want to illustrate with this. Consider 3 vectors, vector P, vector Q, and vector R. And if R is the cross product of P and Q, then R has to be perpendicular to both P and Q. So they are in a plane, and this is completely perpendicular to this plane, which has P and Q. So we can say that P vector and R vector are perpendicular. Also, Q vector and R vector are perpendicular. Let's define these vectors here in terms of our vector A cap, B cap, cross product with C cap. So let's call this as our A cap, and this to be our B cap cross product with C cap. Then this vector here, which is our R, will be our A cap cross product with B cap cross product with C cap, because this is a cross product of these 2 vectors. So this should be 90 degrees with both A cap and with B cap cross product with C cap. I hope that's clear for you guys. Okay, so in this case, I can say that A cap is perpendicular to A cap cross product with B cap C cap. Now we know here that it's defined as half of B cap. Therefore, our A cap is perpendicular to B cap. So what does that infer? That A cap dot product with B cap will be equal to 0. So keeping this in mind, we will proceed into solving the problem. Okay, now given to us is that A cap, B cap into C cap is equal to half of B cap. So let's take the left hand side and let's expand. This can be written as A cap dot C cap B cap minus A cap dot B cap C cap is equal to half of B cap. Now we know that this is equal to 0 from here. So substituting that, we get A cap dot C cap B cap is equal to half of B cap. Therefore, we can say A cap dot C cap is equal to half. We also know that this can be written as magnitude of A into magnitude of C cos theta, which is equal to 1 by 2. Since our magnitude of A is equal to 1, they are unit vectors, and magnitude of C is equal to 1, we get cos theta is equal to 1 by 2. Now theta is the angle between vectors A cap and C cap. So theta is equal to cos inverse of 1 by 2, which is equal to pi by 3. Therefore, the angle between A cap and C cap is pi by 3. Thank you for watching Maths Tutorial Anand. Please like and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.